Synthetic diamonds and diamond-bearing mold powders are used in a number of industries. These include material processing, surface grinding, polishing, drilling, cutting, electronics and optics, semiconductor manufacturing, optical components and laser systems, heat-removing components of electronic devices, medicine, coating of surgical aids, use of diamond drill bits in dentistry, jewelry, a cheap alternative to natural gemstones in jewelry production, manufacturing industry, diamond pastes, and scientific experiments, precision processing of prototypes. After chemical treatment, the synthetic diamonds produced consist of crystals in different grain sizes, the so-called druses. In order to break them down and separate the powders by grain size, because each application field requires a specific powder grain size, ball mills are normally used to break the druses by impacting and ball rolling. This kind of druze processing usually leads to breakdown of monocrystals and does not allow achieving the programmed diamond yield in terms of grain size. Furthermore, ball mills are large dimension, noisy equipment with long processing times and considerable power consumption. Thus, GlobeCore has developed an alternative innovative technology for selective grinding of synthetic diamonds, which is implemented in AVS vortex layer machines. The substance processed, in this case, synthetic diamonds, is placed in the machine's operating chamber along with ferromagnetic particles. The chamber is surrounded by inductors that convert AC power into variable magnetic field energy. The magnetic field has an effect on the ferromagnetic particles, causing them to move intensively and randomly inside the chamber and generate a vortex layer. Intensive movement of ferromagnetic particles ensures their constant colliding with one another, the operating chamber walls, and particles of the material processed. The collision rate is rather high, which, along with a low impact force, provides the necessary conditions for selective grinding of defective and cracked grains. Selective grinding of defective grains results in hardening of the whole processed mass, which means grinding of less hard crystals only and an increase in hardness of output crystals compared to that of input grains. Therefore, increasing or decreasing the processing time of synthetic diamonds in the operating chamber of the vortex layer machine allows producing the powders of the required grain size to be used in material processing, electronics, optics, medicine, jewelry, and other industries. In addition, compared to ball mills, which are typically used for selective grinding of synthetic diamonds, vortex layer machines have other advantages. These include electricity savings due to less power consumption. Depending on the model, one vortex layer machine consumes from 4.5 to 9.5 kilowatts. Compact dimensions and easy integration into the existing process lines of diamond manufacturing facilities. Noiseless operation and easy maintenance. And what kind of equipment do you use for selective grinding of synthetic diamonds? Share your experience of using this equipment in the comments section. More information on the GlobeCore technology and equipment for selective grinding of synthetic diamonds can be found by following the link in the first comment or visiting our website, www.globecore.com.